we've been working with these different kinds of special curves, ellipses, circles, hyperbolas, parabolas that are called conic sections that can all be thought of as slices, as being obtained by slicing through a cone. And I think it's not an unreasonable question to ask. The question I have here on this sheet is half a hyperbola different from a parabola? Do you just stick two parabolas together to get a hyperbola? And the answer to that question is yes, they are very different. And just to convince you of this, I want to look at a couple of graphs. We're going to look at y equals 0.05 x squared, a parabola, and y squared minus x squared equals 1, a hyperbola. I introduced this constant, the 0.505 times x squared, just to make the picture a little bit easier to look at. We're going to go to Desmos here. In fact, I've already plotted both graphs in Desmos. So this is on my tablet, and the blue is the hyperbola, the red is the parabola. And to me, what really sets a hyperbola apart from a parabola shape is its asymptotes. The asymptotes are not drawn in this picture. Again, let me just say, there the red is just the parabola, the x squared. And if I put the hyperbola back, take the parabola away, there's the hyperbola, the blue. The asymptotes are not drawn on this picture, but I think you can kind of imagine where they would be. There's one asymptote here and another asymptote here. So let's put both graphs together, and all I want to do is I'm going to do what's called zoom out. Right now the scale goes from about -10 to 10 in each direction, but if I scale out, I'm looking, it's kind of like going out into space and looking at these graphs from far away. Here I'm now going from -40 to 40 on the x and about the same on the y. Notice that the hyperbola looks more straight, more like its asymptotes, while the parabola still has that nice U-shaped curve to it. I'm going to go out even a little bit further. And as we go out further and further, what this is all about is the hyperbola far away from the origin is really indistinguishable from those asymptotes, from those straight lines. If I just cover up the origin here, it looks like I just have an x. So the hyperbola is indistinguishable from those straight lines. It's almost totally straight. Not totally, but almost totally straight. The parabola, on the other hand, again, still just has that kind of curvy parabola shape, even as I zoom out further and further. Now notice I'm from -150 to 150. So that's kind of my answer to yes. Parabola is totally different from half of a hyperbola. When you zoom out, a parabola still looks like a parabola. There's the parabola. But when you zoom out from a hyperbola, really the graph just looks like a pair of intersecting lines. It looks like the two asymptotes. And we lose all that little bit of detail from that's very, very close to the origin. So I just, again, like this comparison. Here we are zoomed in quite a bit. The hyperbola looks like just a couple of straight lines. If I go back to the home screen, the -10 to 10 scale on the axes, now I can see that both of these are all curves, and there we go. That's it.